Hi folks, welcome to another set of ICP video notes. Today we'll be talking about Newton's second law. So first off, what is acceleration again? You've already learned about acceleration, and it's a change in velocity, which could be a change in the speed, a change in the direction, or a change in both. Remember from Newton's first law that an object does not change its motion unless there are unbalanced forces on the object. You could deduce from that unbalanced forces cause acceleration. So if an unbalanced force changes the movement of an object, then it changes the speed or direction. So when there are unbalanced forces on an object, or in other words, the net force is not equal to zero, there will be an acceleration. The acceleration is always in the same direction as the net force. So for example, diagram A here, it has all of the forces balanced, so there's no acceleration. Diagram B also has all forces balanced, so there's no acceleration. Diagram C has a net force that goes towards the right, which means there's an acceleration to the right. And diagram D has a net force going down, therefore there's an acceleration going down. It's also important to remember that the bigger the force, the bigger the acceleration generally. Well, what about mass? Does mass affect motion? Of course it does. Depending on the shape of the object itself, most of the time more mass means more inertia. Remember, inertia is a resistance to the change in motion, so the more mass something has, the less it wants to move or stop moving. So for example, if you push on a human in the hallway as you're walking to class, you can probably move them out of your way, right? But if there were an elephant in the hallway, you probably couldn't push him out of the way because he has so much mass compared to a human. We measure mass in kilograms. It's not the same as volume, and it's not the same as weight. That may have confused you when I said mass is not the same as weight. There is a difference. Mass is the amount of matter an object has. It's also a measure of the inertia or laziness that an object shows when you try to change its motion. Weight is the force on an object due to gravity. On Earth, gravity is 9.8 meters per second per second. It's an acceleration. Mass and weight, while different, are directly proportional to each other. So every 1 kilogram is equal to 9.8 newtons because we, as you'll see later, we multiply the mass by the acceleration to find the force. So when the mass increases, the force of gravity increases too. So, as we've said, the more mass an object has, the more inertia it has, therefore the more resistant it is to changing its motion, or the more resistant it is to accelerating. So, we can take from that acceleration is inversely proportional to the mass. So the more mass you have, the less it accelerates. Or the less mass you have, the more it accelerates. For example, we have this picture of a brick being pushed here. If you apply the same amount of force to 1 brick, 2 bricks, and 3 bricks, each time you apply that force, the pile of bricks accelerates even less because there's more mass. So if we put all of that together, the more force there is, the more acceleration there is, the more mass there is, the less acceleration there is, we can get Newton's second law. Newton's second law says that the acceleration produced by a net force on an object is directly proportional to the net force. It's in the same direction as the net force and is inversely proportional to the mass of the object. That's a lot of words that I'm not going to make you memorize. Just memorize this equation. Acceleration equals the force divided by the mass. There are 2 other forms of the equation you might use. Mass equals force divided by acceleration, and force equals mass times acceleration. Okay, so let's run through some example problems. Here are your 3 equations that you might use. First question says, if a car that has a mass of 1,000 kilograms gets pushed by a truck with a force of 8,500 newtons, what is the acceleration on the car? So, we're looking for acceleration. We know the force is 8,500 newtons, and we know the mass is 1,000 kilograms. So, we plug it into our equation. If we're looking for A, we're going to use this equation. So A equals our force, which is 8,500 newtons, divided by our mass, which was 1,000 kilograms. if you plug that into your calculator, you should get A equals 8.5 meters per second per second. Okay, the next question says that a car gets propelled forward with a force of 2,500 newtons, and it has an acceleration of 25 meters per second squared. So we write that down. So we're looking for the mass. We're going to use the mass equation. So in this case, M equals our force, which is 2,500 newtons, divided by the acceleration, which is 25 meters per second squared. And you get your mass equals 100 kilograms. It's a really small car, isn't it? So the last question asks, how much force does it take to accelerate a 3,500 kilogram car at an acceleration of 14 meters per second per second? So our acceleration is going to be 14 meters per second per second. The mass was 3,500 kilograms, and we don't know the force, so we're going to use F equals ma. So F equals mass, which is 3,500 kilograms, times the acceleration, which is 14 meters per second per second. If you punch that in on your calculator, you get a force of 49,000 newtons.